Right, okay, so here we have a further stats question about the quality of testing. So we've got the weight of bars of soaps is known to be normally distributed. The standard deviation is 3 and the mean weight is 120. So that means that X is normally distributed, mean, and standard deviation. Giselle believes that the mean weight of the bars of soap is greater than 120 grams. So she takes a random sample of 10. So she's taking a random sample, so we're going to work out a sample mean. Giselle tests this at a 5% significance level, where there is evidence that the bars of soap weigh more than 120 grams. Okie doke. And it says, write down the probability of a type 1 error. Well, type 1 error is where we reject on the basis of our test, but actually it's true. Okay, so it's done at the 5% significance level, so the probability is 0.05 because it has to be in the rejection region, and therefore the largest possible rejection error is 5%. Right, now, given that the true mean of the soap is 122, show the power of Giselle's test is 0.68. Okay, right, so for B, we've got power equal to 0.68. So now what we're going to do, we're going to basically work out P of X bar greater than something, given that the mean is in fact equal to 122. Right, so we need a critical value. So I can use my inverse normal and my distribution to work out what that is. So my sample mean is normally distributed with a mean of 120, and my standard deviation is 3 squared over 10. So remember, the standard deviation is 3 over root 10. We'll put that in the calculator. So, and I want the probability of my sample mean to be greater than something, and I want that to be less than 0.05. So I do my inverse normal, and my critical value is 121.56. So let's put that into our probability. So 121.56, given that the mean is 122, and that gives me 0.6786. Okay, that's B. Now, I want C. So Alex decides to carry out the same test at the 1% significance level. And without carrying out the test, compare the power of Alex and Giselle's test. Okay, well, so Giselle's test was at the 5% significance, and Alex's test is at the 1% significance test. So if we look at it, we can see that for Alex's test there is a smaller rejection region, and if there's a smaller rejection region, that means it has a smaller power. Okay, and therefore, if Giselle's test has a bigger rejection region, it has a greater power, and we would pick Giselle's test. Okay, right, that's C. Joseph decides to increase the sample size and carry out the test at the 5%. So now we've got Joseph getting involved. So he's carrying out 5%. Assuming the true weight, so assuming the mean is 122. Okay, we've got to work out the smallest sample size. So now this means we don't know what n is, and we want a power of 0.9. So power is 0.9, and n is unknown. Okay. So I'm going to go back to my standard normal. I want a z value because I don't know one of the parameters. Remember, this is our standard normal. So I do an inverse normal or use the table to find out what the critical value, which is my Z value at 5%, and that's 1.6449. Okay, so now that means that I've got some value that I want to find. I'm going to call it C minus 120, which was originally what we thought the mean was, and that's divided by my standard deviation, which is 3 over square root of n, and it has to be bigger than 1.6449. Okay, so now I've got that. So now that means that C has to be greater than 120 plus 1.6449 times 3 over root n. And then for this, what I'm going to do, I need probability that x is greater than c, given that my mu is actually 122, and that area has to be greater than 0.9. So I'm going to work out my value of what have I got? I've got 120 plus 1.6449 times 3 over root n minus 122, again over my standard deviation, which is 3 root n, and I want that to be less than negative 1.2816, because remember, this basically is greater than 90. That means that I'm actually looking at 10%. Okay, and remember, these are basically, this is because we're using a standard normal, this is symmetrical. Okay, so I've got that. So that means that 2.9265 times 3 the square root of n is less than 2, and therefore the square root of n is greater than 4.38, and n is greater than 19.26, so n is equal to 20. Not an easy question, but using the same ingredients we normally use. If we've got a parameter missing, we use a standard normal, and when we're talking about type 1, type 2, it's kind of a conditional probability, so we just have to look at what the size of our regions are.